Good morning, everyone. I'm Dr. Abdelmanem Al-Fi. I am assistant professor at Ain Shams University, Cairo. I have, considering our topic today, I've worked with GIS systems since 1999, I think. I've been involved with GIS in some way or another since then. I have given several courses on GIS, extensive courses and crash courses. So this is not the first time. I'm deeply concerned about spatial analysis, geospatial analysis field, and the applications, different application for geospatial technology in our field in urban planning and design, which is my main field of research and work. Today we'll have this. We will start this crash course on GIS. It's basically a 3-day course, around 15 hours. Each day we'll have one session. So Sunday, Tuesday, and Thursday we'll have 5-hour session each day. And in between, we'll have some tutorials. I'll give you the link at the end of each session, some links so that you can take on the tutorials online. We'll be using the software for ArcGIS Pro. I understand that you got your licenses for it from Castle University. So this will be the software we'll be using in the crash course. That's it for now. I mean, we'll start the course essentially on, but I think maybe we go around and introduce each other and our field of study, and if we know anything about GIS before, have any experience with it, and so on.
Do you need us to start, or you're going to say our names?
Yeah, no, I think Muhammad, you can take it for me.
Yes, you can just quickly say your name, and then if you have any experience with GIS.
Yeah,
and it would be also nice if you could open the cameras, so just we get familiar to each other. Afterwards, we can close the cameras when Abdelmanem starts presenting, so it's easier on Zoom. Thank you so much. Yeah, please, Eva.
I'm Eva. I teach at the University of Kassel, and I do research mostly on housing issue, which then includes some mapping. I'm not familiar with GIS systems and would like to know something about it. Yeah.
Thank you, Eva. So, who else? Alisa, maybe you opened your camera, so maybe you can tell us. Alisa?
Yes, hello.
Yes.
Hi, hello.
Yeah.
Sorry for the inconvenience. Hello, my name is Elisa Abdelghani. I'm a PhD candidate at Beirut Arab University. I am familiar with GIS slightly. We had a course at university, but I would love to learn more, of course.
Okay. Yeah, Mahitab, please, you can go
Hello.
on. Hello.
Did we what are you doing now? I wasn't I leave you.
Okay, so we just a quick introduction to yourself and let us know if you have used GIS system before.
Okay, introduction myself. I'm Mahitab Mustafa, lecture assistant, Faculty of Fine Arts, Architecture Department. I take a few years ago GIS course, and I am working on it now because of my PhD applying. My PhD is about urban mapping, urban soundscape mapping with GIS technique, but it was so hard for me to work in ArcGIS, so I am working now on QGIS. And I'm studying on it online, the tutorial in the YouTube, and I'm trying.
Okay, thank you so much. Yeah, Rowan, please.
Hello, everyone. My name is Rowan Walid. I'm teaching assistant at Alexandria University. I didn't use GIS, ArcGIS Pro before, but I attended a 3D course in 2021. But I am still didn't practice, so I hope this course will give me the opportunity.
Okay,
So thank you.
Thank you, Rowan. Okay, we have Amal Fadil. Yeah, please. You are muted, Amal. Amal, you are muted.
My camera and laptop don't
Amal?
open from my phone.
Yeah, okay, no problem.
Okay. I'm Fadil from University of Baghdad. I'm a lecturer and staff academy. I'm now a PhD student. I work in urban, and I want to learn about GIS, but I don't have any experience before about it.
Thank you so much. So we can move to Dunya Tile.
Yes, good morning, everyone. I'm Dunya, a teaching assistant in Alexandria University, Faculty of Fine Arts, Architecture Department. I didn't before practice GIS. Probably this is my first time, and I hope it goes all well. I'm currently pursuing my master thesis in the field of urban architecture too. And that's all.
Thank you, Dunya. Yeah. So Dunya, she is also our coordinator from Egyptian side, and she was the initiator for the project. So yeah, then we can move to Dunya Nabil.
I'm Dunya Nabil, teacher assisting at Faculty of Fine Arts, Architecture Department. I'm finished my master's thesis with title the impact of coastline changes on the city's waterfront. And I didn't have any experience at this program of ArcGIS, but I'd like to know more about it, and it will help me in my master thesis and in my PhD thesis this year. Thank you.
Thank you so much, Dunya. So now we have Sarah. I'm just moving on the names one by one on my screen.
Good morning, everyone. I am Sarah Anani. I'm a lecture assistant in Faculty of Fine Arts, Alexandria University. As well, I'm a coordinator of urban agriculture project. I'm interested in urban and landscape planning and architecture. I have an introduction about ArcGIS. I didn't practice the program before.
Thank you so much, Sarah. So Tamara, you're next, please.
Good morning.
Yeah,
I hope my sound is clear. Yes. My name is Dr. Tamara Amin. I'm a lecturer and also an architectural consultant. My field of expertise is in, of course, it's an architectural design, but it's specialized in crisis management and city revival strategy, which is why I was very encouraged to apply and for the GIS workshop, and hopefully I'll get to learn more, because I've been to the GIS tools and techniques, but it's only for the early stages, and my experience with the GIS is more into the coordinations, or to be specific, it's more about the analysis sheets. So now, hopefully, I'll get to be introduced properly to the early stages of the GIS workshop, or the tools and techniques. And before I forget, I'd like to say hi to one of the familiar faces, Amal Fadil. She's a colleague in Baghdad University. Yes.
Thank you, Tamara. So yeah, now we can move to Said Ramadan. Okay, so Dina Said. Or Said, I don't know. Said or Said?
Dina Said.
Okay. Can you open your camera, Dina, if possible? Also?
Good morning, everyone. I found a problem. Sorry.
Yeah, no problem.
I am a lecture assistant at Faculty of Fine Arts, Architecture Department. I didn't use GIS before. I wish to use it my PhD. My topic about how to build a framework in recycling urban design. I wish to use GIS net. Thank you.
Yeah, thank you, Dina. And then we have Munir or Said. Are you there? Okay. Okay, then we move to Munir Mekesh or Mekek. I don't know the right pronunciation.
Hello, can you hear me?
Yes.
Okay, good morning, everyone. I don't have a webcam for now, but I will get one for next time.
Okay.
I'm a soon-to-be architecture student at University of Kassel. I have no prior experience with the software, but I would love to learn more, and thanks for having me.
Yeah. Thank you, Munir. Okay, so and then we move to Umayma Al-Tai.
Good morning, everyone. I'm Umayma Al-Tai from the University of Babylon, Iraq. I'm architect and sketcher and the writer, and now I'm currently on my master topic, urban acupuncture. So I'm very interested in this project in general because I think it will help me in my topic, in my master topic. That's enough.
Yeah, thank you so much, Umayma. And also to mention, Umayma, she's the coordinator of the project from the Iraqi side. And then we can move to Magali Malkangi. Yeah, please.
Hello, good morning, everyone. My name is Magali Malkangi, and I start my first semester at Kassel University in October. And I have no previous knowledge or experience about GIS systems.
Thank you so much, Magali. Natalia. Now we can move to Natalia.
Yeah. Good morning, everyone. I'm so sorry not to switch on the camera because I'm struggling a little bit with that. Anyway, I'm a PhD student, like exchange PhD student from Ukraine at Kassel University, and I'm dealing with environmental issues. I've had an experience with GIS, but I definitely into the point of learning more, and thanks for having me today.
Thank you so much, Natalia. Now we can move to Shireen Tarabulsi.
Hello, my name is Shireen Tarabulsi. I'm sorry I'm not able to open the camera right now. I'm a PhD candidate at Beirut Arab University, and I am familiar a little bit with the software, and I'm very grateful to be here. Thank you for having me.
Thank you, Shireen. Now we move to Aya Shehab.
Hello, everyone. Hope you're well. My name is Aya Shehab, and I'm a lecturer in the Faculty of Architecture, Design and Built Environment in Beirut Arab University, Lebanon. And I do have a slight knowledge about GIS as a whole, but I'm looking forward to further increase this experience, as I believe it will aid me in my PhD dissertation further on. Thank you so much for the experience.
Thank you so much, Aya. So now we have Aya Al-Ubaidi. We can move to Noor El-Baba.
Good morning, everyone. My name is Noor El-Baba. I'm a lecturer and PhD candidate at the Faculty of Architecture, Design and Built Environment at Beirut Arab University. Actually, I'm familiar with the software and I'm using it as a tool in my PhD related to urban design and planning. I would like to extend my knowledge here, and I'm also now getting into ArcGIS business analyst just to know, because it integrates with my thesis topic. So I'm familiar with it, but I want to more elaborate on my knowledge in this workshop. Thanks for having me here also.
Yeah.
Thank you.
Thank you so much, Noor. Now we have Hadir Hawash. Yeah.
Good morning, everyone. I am Hadir. I'm an assistant lecturer in Alexandria University. I'm not that familiar with ArcGIS. I have used QGIS before, but mainly in the process of drafting and using maps, but not in analysis. So I'm interested in spatial analysis, mainly in this course. Thank you.
Thank you, Hadir. Now we can move to Ayat Nejm.
Hello, everyone. I am Ayat Nabar from University of Babylon. I am master student and I use GIS in my thesis application by ArcMath. and I excited to attend this workshop.
Thank you, Ayat. And we have at the end Hetgat.
Yes, good morning. I'm studying architecture at the University of Kassel, and I haven't used GIS systems yet, but I'm very thankful that I can be part of the course today.
Thank you so much. And El Said, are you there, or Ramadan, can you hear us or you cannot? Okay, I think maybe you have something, a problem with your mic, because we cannot hear anything. So maybe you can just get out and inside again. It might work fine afterwards. So yeah, just regarding myself, I've been using GIS for almost 10 years now. Also, I got my first course by Abdul Manam and another colleague from Ain Shams University, Dr. Sami Afifi as well. So they have taught me the basics, and then I have took my path using different tutorials from Esri online. So yeah, this is from my side, and now I can move back the mic to Abdul Manam, so you can start and share your screen. And at this point, I would kindly ask you all to turn off your cameras so you can see the screen better when Abdul Manam starts sharing.
I have a question. Just
yeah, please.
Yeah, please. I just was wondering if I can use my already built account on ArcGIS Pro from my university, or I have to, or is it an obligation to log in?
No. You can
Yeah?
use that. No, we provided the license from the University of Kassel because some universities either don't have the license to work on.
Yeah.
Or others that might have some other problems due to the schedule at the university that they cannot use the laptop. So we prefer to provide the license so each one can have a personal license that they can work on during the workshop. Yeah. So
I can use it. Okay, thank you.
Yeah, you can use either of them. It's your own choice, because just for you to know, after we finalize the presentations, the license for this workshop will be expired from Kassel University. It's just for the purpose of the course.
Okay, thank you.
Thank you so much. Yeah, Abdul Manam, now the floor is yours.
Okay, we can start now. As we move along, I think we will have some questions, or you will have some questions. So at the end of every section of our session, we will stop and take all your questions. So if anyone has a question, maybe you can write it down in the chat. Mohammed can keep track of them, and we'll come back to them at the end of each part of our session, inshallah. I hope you can see my screen.
Yes, I can see it properly.
So as we said at the start, our session today, or our session in this week, is about an intro to geographic information system, and it's in a crash course format. So during our session today, we will be talking a bit about the history of GIS as a whole, the history of Esri and the start of ArcGIS systems, and we will have a preliminary introduction to the program ArcGIS Pro, which we will use later on in the rest of the course. If we're looking at geographical information systems, I mean, GIS, Geographic Information System, Geo Information System, it has a couple of names. The acronym itself is about information systems and how it interacts with the large domain of the geoinformatics. The idea of placing information systems in a spatial context is not really new. It started with the start of us making maps. When we made the first maps, turned our real world into a 2D dimensional representation on a map. This was maybe the start of creating the first primitive GIS systems. Maybe the oldest known examples we have right now, the oldest documented one start maybe in 1832. A French geographer called Charles Picot represented the districts of Paris by halftone colors to create, they were trying to map out the deaths caused by cholera on a city map. A more concrete example maybe is in 1845, a public health official by the name of Dr. John Snow were trying to find out where they had a cholera outbreak as well, and they were trying to find out where it came from. And we have this idea that the cholera came from the water supply of the city. So if you look at this map here, this is a map of a district in London, and basically the crosses that we have here are the water bumps that they used at the time. And he had this idea that one of those water bumps were the cause for the infection, and he started actually placing on the map the infection cases in those dots. And as you can see, by the clustering of the dots, we find here that there is one water bump that is actually in the midst of the clusters of the infection. And what they did at the time is that they simply removed the handle from the water pump, and the cholera outbreak in that district stopped. And this is one of the oldest, and we can say one of the most prominent examples of using GIS technology. And of course, this is basically all analog. It's just paper maps and doing it by hand. Turning more into the digital field, we start at the early 20th century when we had an idea by Professor Ian McHugh about something called map overlays. And the idea is basically that we can take the real world and start splitting it into different layers. So we have a layer for the land use or land cover, we have layer for land ownership, a layer for the vegetation, for the hydrology, for the soil types, and so on. And by basically splitting the world into this different layers and then fitting them together again, we can start seeing the world in a different view. And this idea of map overlays is considered one of the fundamental tenets of GIS technology. And this brought, of course, Professor Ian McHugh as one of the fathers of modern GIS. If we move to some others who can still call also fathers of modern GIS, we find Dr. Roger Tomlinson, and he created or founded the Canada Geographic Information System in 1960. It was a system used for the Department of Forestry and Rural Development in Ontario, Canada. And it was used to collect the land inventory and store, analyze, and manipulate this data. A second system started or showed in 1964 by Professor Howard T. Fisher, who actually created the laboratory, founded the laboratory for computer graphic and spatial analysis at Harvard Graduate School of Design. And it is contributed to this laboratory the founding of many of the systems that are still in use today, like some of them are still in use today, not all of them, but some of them, like CMAP, GRID, and Odyssey systems. As we say, this is 1960 or 1964. We move a bit to the era of the personal computer, and we're in the early 1980s, and we find that several private companies started appearing on the stage, and they started offering their own softwares. So we have Intergraph, we have Esri, we have GIS or MapInfo, we have Bentley Systems. They all, Das Imagine, they all offer their own version of software that dealt with GIS systems. And at the same time, we also have certain some endeavors to create what we call public domain, or what is known now as open source softwares, like the GIS and the MOS softwares, which appeared in the late 1970s and 1980s. Those softwares, the shift in the 80s led to a rapid development of GIS systems until we reached the end of the 20th century and early 2000, when we started having much more mature applications for GIS systems, and one of them is ArcGIS, which is the forefather of what we have today, which is ArcGIS Pro. Okay, why is GIS important in our study? GIS enables us to have several functions that are actually not possible without it. It gives us the ability for data management, the idea that we can right now we are in the era of the big data. We are collecting data from everything, from everywhere, and managing this enormous amount of data that usually have some form of a spatial component cannot be done without having some form of a GIS system. It allows us to do asset management, basically allowing us to schedule maintenance and management for infrastructure data. It gives us field mobility, the idea that I can go down in the field and start collecting data. We used to do that by hand. And as it becomes more and more complex, the applications that we're using, right now, the idea of collecting this data by hand is rather ridiculous. What we do now is we go in the field, we have some form of a GIS system on our tablets or in our laptop, and or in our mobiles, and we start collecting the data in the field and doing direct assessments right there in the field before going to the office and continuing our work. The idea of operational awareness, which comes with data integrational, integrating all the data that we are collecting from different sources, gives us the capability of looking at a much wider picture than if we're only looking at one source, at one set of data. GIS allows us to see from different sources, from different perspectives, and at different levels. Of course, planning and analysis at all levels, whether we're talking about planning and operation, or urban planning, or regional planning, or landscape planning, whatever the level we're talking about, we have assistance in it that allows us to get what we call actionable information. And of course, customer service is one of the higher demand for GIS systems today, as it's used by any company that works in customer service or have a branch for customer service. The idea that you can couple your data with spatial information and the analysis that it can give you, so that you can respond more quickly or faster to the demands of your customers, and at the same time more efficiently. We move here to the idea of spatial analytics. The GIS systems, when we say that it helps us in this and this and this and enables all those amazing functions, is basically because of the background of spatial analytics. We can do site analysis, we can do watershed analysis, resource inventories, land management, network analysis, whether those are road networks or infrastructure networks. We can do incident mapping. We can have measurements, spatial measurements. We can define corridors, which whether it's corridors for different organisms in spatial habitats or whatever. We can use it for logistical routing, which you usually see in companies, of course, like Amazon or something like that, who do e-commerce. We can use it for facility management. There is even a version of GIS that basically works indoors, not in the outdoors. We have also the function of geoprocessing. We'll talk about it briefly on our third session. We can check the spread and diffusion of elements in the field, whether those are pollutants or whether those are air or temperature or even animals in a field. We can also use it for topographic analysis or use it for demographic analysis, which is a social construct. So, considering all those functions that we're using GIS on, we can say, and what the technology is enabling us, and how it's changing very fast. I mean, in the last, I would say in the last 20 years, yes, there was great improvement in GIS technology, but maybe the last 5 years, the improvement have been considerably rapid. Functions that we have every few months, we have new functions, we have new applications, we have new analysis models that pop up here and there, and it's changing how we do everything. It's changing how we are measuring the data, how we are analyzing it, even the idea of visualizing the data. There is always new ways to visualize the data, and which is a very important thing. You have to understand that whatever the analysis we're doing, at the end of the day, we will move that data to someone who might not be a specialist. And the capability to visualize the data in a simple and apparent way is one big aspect of GIS that we have. It also helps us in the designing, planning, and decision making. We can use it while acting in the field or while implementing data. So basically, everything is now changing due to that. The changes, if we try to look at it, we have the way we abstract. If we try to divide it into categories, so it changes how we're abstracting our world. Basically, everything that when we build a model for reality on our devices or on our GIS systems, that model of reality is an abstract of the reality. We can never build a complete model of reality. It's an abstract vision of it. And even this abstract model, as the technology advances and changes, our ability to abstract things that we couldn't do before is now more apparent. So how do we build those models? how to build the workflow, our data and data models. Those are changing. We're also changing our ability to find patterns, processes, relationships between the different entities that are in those models, and by relation are actually in the real world. And of course, it allows to organize and communicate better, collaborating with different partners and different entities. Okay, moving on, we'll start looking at what we say the components of GIS in general. So GIS systems, and this is true to any GIS system, it doesn't to any software. I mean, GIS, you have to think of it like this. There are softwares and there are the science or the discipline of GIS. Softwares, there are many and numerous, and you can choose whatever is available for you or whatever you prefer for any reason. But the science is one. Even between different softwares, when we're the terminology is one. So if a function has a name in ArcGIS Pro, it's the same name in QGIS, it's the same name in GRASS. The names don't change. It's one terminology because of the science. So when we start at the basic components of a GIS systems, any GIS system has a hardware component, a software component. So we have the hardware that will carry out our software. We have the methods we are going to use for analysis and for processing the data that we are going to collect either from the field or from other resources. And the final and one of the most important component of a GIS system are the people doing the work. Either they are collecting the data, running the hardware, running the software, the ones who are planning the analysis and the procedures that we are going to use in our methods. Human factor is very, very important in a GIS system. It's the brain behind the operations, as we say. And when we work in the GIS systems, we usually have three views. We have the geovisualization, which is basically the maps that we create for the world. We have the databases, which carry all the info of the real world into our hardware. We call it geodatabase. This is the term we use. We call it geodatabase. And we have the geoprocessing element, which is basically analysis models that we create to analyze the data for a GIS systems. And we usually, while working, we are working on one of those three views. We are either managing our geodatabase, or we are managing the models and the spatial analysis, or we are doing the visualization. And I can say for sure that each one of those views could be considered a branch of science in its own. There are people who work on one of those, basically is their own focus, and they don't maybe just touch on the other two briefly. Okay, how do we view the data on GIS? This is very important, and it will and this will carry with us throughout the course and throughout working with GIS. Any GIS systems see the data in two views. We have the geographic view and we have the tabular view. In the geographic view, we have the map, the elements on the map, which we usually call features. So each of those polygons, for example, is a feature. And those features must be represented as they are represented geographically. They must be represented in a tabular view. Each feature will have a row in our table. So that feature, for example, the one that is in a yellow color, has a row in our table, and this row carries data about the feature. So it carries a unique identifier number for it. It carries its area, its address, some form of code. Here we have the owner, we have acquisition date, we have the price for this piece of land, and we have a tax stat, for example. And this is repeated for each feature of those. And we look at it. This is the geographic view, so those are the features. And this is the tabular view. This is how it looks in the expanded format, and we usually call it the attributes. So we have features and attributes, and this is common to any GIS system. And this will basically be part of the basic and pertinent tenets of GIS. Any GIS you're working with, you'd have features and you have attributes, and you can't have one without the other. Okay, moving on, we are moving to the main functions of a GIS system. There are 6 functions of any GIS system, which start with capturing data, storing data, querying the data, analysis, display, and output. Capturing data is the idea of capturing data. We have multiple sources of data, and we start to collect this data from those different sources, whether those sources are paper maps, this is possible, or it is in digital format, or it's from GIS, or from direct coordinate systems. Paper maps is, I'd like to say it's winding down, but in some places you still find the data in the format of paper maps that we have to digitize and place on our systems. It's not 100% proof. Digital data, a lot of data nowadays is in digital format, and we can collect it from different sources. That comes from sorry, that creates its own hassle, so to speak. The idea that it comes from different sources who created data in different formats, and we have to unify all that to work with it on one unified system, integrate all the different data sources together. But being in digital format makes things easier for us. We are collecting data from GIS systems, from satellites, and sometimes we even get it as XY data, just pure XY data, XYZ even, and we can input that directly to our database. Now, when we move on to storing the data, we have an important decision to make. Are we storing the data as vector format, or are we storing the data as raster format? It's an important decision we all make, and it basically defined by what are we going to use the data later on. So we plan, when we plan our geodatabase, creating our geodatabase, one of the questions that we do when we plan it is, how are you going to use this database? What sort of analysis or geoprocessing are we going to use? And based on that, we decide how to store our data. Are we going to, most of the analysis we run is actually on vector data. So I don't need my data in raster format. Or no, I need it in raster format because most of the analysis will be in raster. Or it's a mix between the two. If we look at it, we find that in vector data, we have discrete representation of reality. This road in the picture, when it's represented as a vector, it's basically just a line, or maybe we can see it as 3 segments. It could be considered as 1 segment or 3 segments, with each having its own attributes in our tables. But when we look at it as raster data turns everything into cells. It's the equivalent of a cell is the equivalent of a pixel when we talk about graphics. In GIS systems, it's usually, we call it cells, and we can see that the number of cells that represent this highway is considerably. Maybe we're talking about 40, 50 cells to represent just this one highway, when it's in vector format was only 3 distinct segments. So just the multiplication on the amount of data that we have to gather and store is immense when we move to raster formats. But sometimes the analysis we have to do cannot be done on vector. We have to do it on raster, and so that's how we're going to store our data. Okay, once we have the data stored, we are moving to the third function, which is querying the data. Query is basically asking very simple and basic questions to explore our data. It could be as simple as basically clicking on one of the features and having a window open us to us so that we can see the data of that feature that we clicked on. Whatever data we have stored with it, we can simply see it. So it's basically identification. Or we can move more and start making some more purposely formulated query, like saying here, okay, this is Florida, and I'm going to look at the counties with a population that is greater than 300,000, and it lights in the map, and it lights also in the attribute table. Okay, those are the counties that have a population greater than 300,000, and this is more of a complex query. It allows us to we have more purpose in it. And as I said, query is only for exploring what we have. We haven't started the analysis yet. The analysis moves into more complex format, and it has its own designation. Is it proximity analysis? Is it overlay analysis? Is it network analysis? When we say proximity analysis, we're basically trying to identify features based on their spatial relevance to other features. So when we say here, which of those parcels are within 50 feet or 50 meters from this road, the road in red, and we're trying to find the parcels inside the parcels that are within the 50 feet limit of that road, and we select those parcels. Basically, we selected those parcels based on its relative spatial position to that road. So this is a proximity analysis. There are different types of it, and we'll talk more about that tomorrow. But this is one of the analysis. The other is an overlay analysis. Overlay analysis also depend on the spatial relation between the different entities. For example, here are the layers. If you remember several slides back, we talked about the overlay, the overlay mapping, and these are the overlays. We have a layer here for wells that are drilled on the ground. We have another one here that shows a river or a stream, one here for the ownership, and one for the type of the soil. If I aggregate all those together, I can collect more data. I can say, okay, the well here is drilled. It's owned by the owner of that land, or that parcel of land that we have on this layer, whose name is Smith, and it was drilled in what type of soil? It was drilled on sandy soil. So basically, by overlaying all this data together, we are getting more data we didn't have before. And of course, network analysis, which is one of the most prolific type of analysis that I say prolific because we use it in everyday life. When we use our Google Maps and start saying, I want to go to this location, and how would I drive or ride or walk to that location, and the Google Maps simply just draws a line on the map from this point, from this origin to this destination, and it will take you how many minutes. This is a form of network analysis, and it's used by everyone. There are different types and different modes of analysis for that, but this is one of the most general and most known to the general public. In the example here, we have the image is basically, this is the hospital, this is the accident site, and we are creating, or we're doing the analysis for the shortest route for the ambulance to reach this accident site. It's a bit different from the one we use in Google. It's more has to be more efficient and has to have higher rigor factors to it, but we're looking for this shortest path. And of course, when we look at shortest path, it's not just the distance, it's distance and time together, and how do we factor the time. And sometimes we have live data, or we should have live data to do it, to be able to know this is a congestion in this junction of the road, or there is a work being done here or here, so that you have to divert from that road to take another road. It will be the shortest path for you. So those are three types of analysis that we use in regular basis when dealing with GIS. The fifth type of function is the display. Displaying the data is a science of its own. We have studies, full studies on the on visualizing the data. How are you going to visualize this data? When are you going to visualize the data on maps or on graphs, or create a report? How do you integrate between the three different types of media? Are we going to create 3D representations, or are we going to do work with 2D or 2.5D sometimes? Is there going to be some form of motion, or something like a movie that is going on in the data? I mean, it's not just stand still. It's not just a picture we're going to see. As I said, it's a whole field of study. Visualization is a whole field of study, and it's really very purpose oriented, because we can lie with the data, and this is a very real concern when using GIS or any form of data-oriented analysis. If we don't show the most relevant data, the most relevant parts of our analysis are the results that we get from our analysis, we are obscuring the facts, we are obscuring the truth, and we are lying. And we might do it unintentionally by simply deciding on some color, or some representation, or some form of graphs, or some form of 3D that basically obscure the data, when we are not focused about what we are going to show, why do we show this. And so the study of visualization is not just some people hear the word visualization and they think graphics, and it cannot be far from the truth. Visualization is about the art of showing the relevant, and it's very, very important to choose the best technique for showing the most relevant data to us, or to the analysis we're doing. And finally, we already visualized our data. Now we have to move into giving outputs that were going to be used by the different actors who are going to view our data. Paper maps is always there, but it's becoming more and more outdated. No one is using it I wouldn't say no one is using it anymore. It's there, but it's not the main output that maybe 15 years ago, it was still one of the main outputs. Now, not so much. Now more we move to the internet-based or web-based maps. We create storyboards, we create dashboards to allow people from different places to interact with our data, and even sometimes not just view our data, but interact with it and give us feedback, or even collect more data from them to add to our databases. So web-based maps is now one of the most important applications that we have. And of course, we can get some document, whether in the form of a map document or a project file that we can share with our colleagues or with our clients, or we can get just image in image format that we can just also share locally or over emails and so on. So those are, as I said, the main functions of a GIS system. Before moving to the platform and start talking about GIS, we have a view of or a brief representation of what are GIS platforms that exist today. We have ArcGIS. The version we're using now is ArcGIS Pro. We have GeoMedia, we have MapInfo, we have Small World, we have GRASS, we have GV-SIG, and we have QGIS. All those you'd find that, as it's written here, this is the software and this is the programming language or that we can use to customize the system. Why did we show it like this? Because customization is one of the very important aspects of any GIS system. While doing analysis, as it becomes more versatile and more complicated, we sometimes just move to, I want to customize this function. It may be just changing a line of code or changing a parameter or something like that, and it gives you a different whole type of different analysis that you couldn't access before if you use the pre-programmed systems. Nowadays, this customization is becoming easier. Yes, there are a level of GIS operators that are developers, that are actually program developers, and they are on a level of their own. But even GIS users, normal users, can do some small customizations. There are customizations that we can simply just already done by someone else on the web, and all we have to do is incorporate their code into our code, and we don't have to do a lot of work. We don't have to be programming wizards to do it. We maybe just have to have basic knowledge of programming languages. And as you can see, many of the most relevant, like ArcGIS and QGIS, use Python as main programming language. If you check the map here, the map is just showing what is the most relevant software. So we have Esri ArcGIS is the one that is most prevalent, followed by QGIS, maybe GrashGIS, and then we have Saga, MapInfo, GeoMedia. They still have their uses and they still exist, but those are the main two important ones. Of course, Esri ArcGIS, you have to have a license, you have to pay for it, but QGIS is an open source, and it has a lot of functions. It has a lot of potential for customization, and you can actually do a lot of the work that we do in license formats on QGIS. So it's actually a very viable option. So at this note, we take a we stop this session, and if you have any questions about what we talked about before.
Yeah, so if you have any questions, please feel free to raise your hand so I can take your questions. You have no questions? Is everything clear for you regarding this theoretical background?
Yes, everything is clear to me.
Okay.
For me personally.
I have a question. Excuse
Please,
me.
Amal. Please, Amal.
When I received the email about the download the program, the application, I have 3 files. One of them cannot download, and the application don't work on my desktop.
Okay, Amal, can you send me this to the email? I will check it for you. Send it to me on the email. Yeah, please.
Oh, thank you.
Do we have any questions regarding the input from Dr. Abdelmanem? Okay.
Okay, I have a question for you. What sort of license did you give them? I mean, did you give them an account?
Enterprise license. They got an enterprise license through our university.
In the form of an account username and password, or in the form of a file that they download on their PC?
They download the file to the PC and they have a username and password too, because for the ArcGIS Pro, they have to have a username and password to get connected to ArcGIS Online.
Yeah.
So they have all of it. They have all of it.
Okay. So our next we're going to start about talking about ArcGIS. So maybe we get a 5-minute break, and we start after that about ArcGIS, talking about ArcGIS, the software that we're going to be using during our sessions. Okay, so just 5-minute break. After this introduction to GIS in general, we're moving to the program itself that we're going to use during the sessions, and it's ArcGIS. To start talking about ArcGIS, so we have to talk about Esri for starters. Esri is Environmental System Research Institute Incorporated. It's a research institute / company that was formed in 1969 by Jacques and Laura Dengermond in California, Redlands, California. They were one of the first, and we can say the pioneers of GIS technology, and having it into a format that could be used by everyone, not just big mainframes of companies and governments as it was at the time. It made it more accessible to researchers and users everywhere. GIS, what we see now, what ArcGIS we see now, was something that was developed through many years. First, they had something called ArcInfo. ArcInfo was a software that was basically first it used to work on DOS. There was no Windows at the time, so it used to work on DOS, and then it moved later on to Windows. Many of the functions of ArcInfo was use command prompt, so you have to write some form of code for the commands, the different commands to run. It didn't have really a graphical user interface like we're used to right now, but it was a considerably robust software, and it was hard. Not everyone could use something like that. It wasn't really an accessible one. To create one that was accessible, Esri created something called ArcView, which at the start of it was something, it matched the name. It's ArcView. It's a viewer for the data that actually comes from ArcInfo. So whatever you do on ArcInfo, you do the real work on ArcInfo, and then you view that data on ArcView, or at least that was the start of the ArcView. And then as years go by, they started to add more functionalities to ArcView. It never matched ArcInfo, but it has some functionalities that users that were not really proficient with programming could actually use it. Starting from the early 2000s, ArcGIS came to the stage. Before that, there was no ArcGIS. It was ArcInfo and ArcView, and then suddenly we had ArcGIS. ArcGIS started with something called ArcGIS 8. I don't know what happened to the other numbers before that, but it's ArcGIS 8. And we used ArcGIS, many people still use ArcGIS till now. We are in ArcGIS 10.8.2. This is the version that we have now, and it's basically ArcMap. It's the main software of ArcGIS of that format. It's called ArcMap, and this is basically the last iteration of it. Esri is no longer going to add any more patches or any more updates to ArcMap beyond this year, 23, and it will be considered a discontinued product by 2025. The main program that we're using now, which is ArcGIS Pro, and which was introduced in 2014. This will be the main product of Esri, and it will be the main thing we use, of course, with other softwares or other platforms that they are already creating every year. And it's basically, as you see here on the slide, it's an integrated system. You have apps that you can have on right now, the system that we're working with. You have apps that you can have on your mobiles or on your tablets. You have the desktop application, which is in our situation ArcGIS Pro, or something like City Engine. We'll talk about it briefly later. And you could have the Enterprise Edition. Those Enterprise Edition are softwares that you actually install on servers and mainframes. They are not for a normal PC. You have ArcGIS Online, which is a big thing, and we'll have one of your exercises today or tutorials will have to deal with it. And you have, of course, the APIs and SDKs, which are the development tools for developers, whether you are developing on the servers, developing applications on the server or on the desktop, or for the apps that we have on our mobiles and tablets. The main three branches or platforms that we are using now, or that we have now access to, are ArcGIS Online, ArcGIS Pro, and the ArcGIS Enterprise. As we said, ArcGIS Enterprise deals with servers, and so is out of our scope at the moment as a crash course. And we have the ArcGIS Pro, which works from a desktop. I heard a discussion earlier about what platforms it works on. It actually works on Windows and Linux. So you have a version for Windows, a version for Linux, and if you want it on a Mac system, you have to work it through a virtual machine. ArcGIS Online is accessible from any browser. Just go into the browser, www.arcgis.com, and when you're in, just log in with your username and password, and it opens up the application ArcGIS Online, and you can start with content you uploaded before from your ArcGIS Pro, or you can pull up content that are available somehow in the public domain on the Esri servers. So it's not really public domain. I mean, it's someone created this this data and placed it on the Esri server, and it has some form of an ownership, but you can use it on ArcGIS Online, congregate data together, and run some form of an analysis on your web browser. And some of those analyses are quite sophisticated, so you can actually use the platform to run considerable amounts of analysis. whatever the analysis you're running, in the background, we have what we call the analytics. You have the maps and the scenes, you have the features, feature layers or scene layers. Feature layers are usually 2D. Scene layer is something we say when we have a 3D. We have tiles, we have image layers, which could be satellite imagery or could be raster data in general. And we have the analytics. We can do the analytics for all that. And this is basically whether we are using the web or mobile apps or the desktop apps or the developer tools. Basically, those are the what we use to access all this data. Even on desktop apps, we can access data either on our PCs or online, because in ArcGIS Pro, when you log in with the username and password, you're logged in two systems. You are logged in the desktop system, and you can load data from your own hard drives, or you can actually load data from the ArcGIS online repository, and you just load data from there and work it with your desktop data as well. Working with the different data we have, you can have applications that you could use in the field, like the navigator, the workforce collector, which goes into, we have a software called Survey 123, one of the very interesting software that you can use in the field. We also have workforce navigator and collector. I think one of them is going to be integrated with Survey 123 this year or next year. The office or the desktop, you can have, there are plugins. We are talking here, we have the desktop application ArcGIS Pro, but you also have plugins that work with other softwares. So you have one ArcGIS for AutoCAD, or you have maps for Office. You can have the ArcGIS plugin for Excel or for Word files or for PowerPoint. Many people use it with Excel because they have you can do some manipulations on data and create maps actually inside Excel and then use them. You have ArcGIS Earth, which is a standalone software. You have also Explorer, and then we have the dashboards. During COVID, I presume many of you have seen this website that were made by Johns Hopkins University about the spread of the virus and the cases. Day by day, they had data information about how many cases there are in each country of the world, and they have this big map of the world with red dots on it about how many cases, and some graphs on the sides and on the bottom. This is actually a GIS dashboard that was created by Johns Hopkins with collaboration with Esri, and they basically left it online. I think it has updated data till March of this year, I think. We can check it, but I think something like that. It's still on. You can go into it if you have the link, but it's not updated anymore. But this was a dashboard that had almost real-time data. It was updated daily, and you have many info, and we can create such dashboards for any project that we want, and have it online for others to view and interact with. After that, we have, of course, the public view, which opens us to story maps. Story maps is something like a website that we create that has info, maps, and graphs. It's basically like a journal or a blog that we can create with interactive maps inside of it. And one of your tutorials today, you'll set up one. It won't take a lot of time, just I think 20 minutes. And that's the beauty of it. You can set a story map in very little time. You can have open data for people to access on the line. You can have photo survey and crowdsourcing applications, which is very important nowadays, because some of the data we need to collect might not be in a survey office or in a governmental building. Some of them might have to be collected on the field, and some of them cannot be just collected by sending surveyors in the field. Some of them really need some form of crowd sourcing. So this is basically about the platform. Now, basically on the platform of GIS, you have to speak about licenses. ArcGIS is all about licenses. This is a bit outdated because it still says, if you see here, ArcView, ArcEditor, or ArcInfo. When ArcGIS moved from the ArcInfo and ArcView platform and created the new platform, which is ArcGIS Desktop, which has ArcGIS or ArcMap, they created 3 licenses that were called ArcView, ArcEditor, or ArcInfo. This is the basic license, the standard license, and the advanced. Nowadays, no one says ArcView, ArcEditor, ArcInfo. It's basic, standard, and advanced. Those are the licenses we use. And it's basically what does every license offer you. The basic license basically offer you seeing the maps, seeing the database, not much of analysis of any sort. We can just see it and make some displays. The standard offers some more ability to go into more analysis, and the advanced basically opens all the tools to us. We can do whatever we want to do with it. And as I said, this is the, I mean, I left it because it's it's outdated, but I left it because it's most apparent about what the license offer you. But if you want to know what every license offer you, this is the actual tables where you say advanced, standard, and basic, and basically they list here on the side whatever they do in map creation, interactive visualization, and spatial analysis. This is those functions, and there is another one for multi-user editing and advanced data management. Once we go here, the basic doesn't have any functions, and it's always the advanced and the standard. And then moving into the advanced analysis and the high-end cartography and extensive database management. And when we go to that, you find that it only in the advanced. I believe the license that you have should be for the advanced license, right?
Yes, they have the advanced one.
So basically, the advanced license offer you the full suite of the program, and it's all of its functionality. And that's usually how Esri offers its license for the academic institutes. If it's a company, they usually companies, because it costs much more for companies to buy it, they will check which license actually they need. Not everyone gets the buys the advanced. It's really expensive for companies. Okay, do we have any questions until now? No questions?
Do you have any questions? Okay, I have added to you in the chat the dashboard that Abdelmanam already mentioned regarding the John Hopkins, and also a link to the different licenses that ArcGIS, that Esri offers for ArcGIS. So also you can read more about that if you need.
Yes, great. So moving on. This is also some info that we have to see now. We use it later. ArcGIS deals with what we call spatial data formats. There are different spatial data formats. Of course, there are ones that we all know, like CAD files and raster data, which are usually image data. CAD files any CAD file that we work with, any CAD software, you could get the CAD files and view it in ArcGIS. And this is the operative word, view it. You can't edit it in ArcGIS. You can simply view the files and maybe export some elements of it inside your data, but you can't edit a CAD file in ArcGIS. We can also view what we call raster data. Now, raster data is not just JPEG and PNGs and so on. No, we have TIFF files, and it's called GeoTIFF because they come from satellite imagery. You have SID, also a satellite image format. And so this is also something that we can use, just not normal imagery, but also we can use satellite images. We can load it inside the interface of ArcGIS and do some analysis on it and use it. We'll have a quick view of that later. And then we have the formats that are actually GIS formats or ArcGIS formats. We have the coverage, which is actually a legacy format from the days of ArcInfo, when ArcInfo was the first software they did in the 70s. This is the format that it used, coverage. Coverage is a very robust format, and for a long time, it was the format for anything from Esri, and even later formats never lived to its potential. Later on, when they made the Arc view, they created another format, which was the shapefile format. Shapefile format is a much lesser format compared to the coverage. It's meant to be transferable, easy to transfer between individuals, and it was used mainly for viewing data. Later, more functionalities was added to it. And shapefile is important because I'd say it like this. Till today, we sometimes get data in shapefile. You will not see data in coverage. Coverage is maybe, I think the last file in coverage I saw was in 2006. That's the last coverage file I ever came across in a project, 2006. But shapefiles, I still see shapefiles till today. It's not as much as it was 10 years ago, but until today, you might find some data coming to you in shapefile. Geodatabase, now this is the format that Esri came up with when they made the ArcGIS desktop, ArcGIS ArcMap, and so on. They started with something called personal geodatabase, and then expanded to something called file geodatabase, which is the main format used today. Personal geodatabase was actually an access file. If you're aware of the Microsoft Office program suite, there is one program which is Microsoft Access. It's a database software used to building database and managing them, and they used the format of that file. I think it was an MDB file, and they created something called a personal geodatabase. And it was what we used for a very long time, since the early 2000s when we shifted to ArcMap, and it still exists till today. There are a lot of projects that are made on personal geodatabase. Now, with the shift to ArcPro, ArcPro does not directly access personal geodatabase. You might find a personal geodatabase, and you have to either transform it to a file geodatabase, which there is tools to do that, or you can create something we call a project file and open that in ArcPro so that we can access the files from the personal geodatabase. And we also see that, I know it's a bit confusing, but it will have some relevance later on. So the format that we use nowadays is called file geodatabase. It's not a format. It's not something dot something. It's usually a folder. It opens a folder on your hard disk with the name, whatever name you named your geodatabase, and it stores many files inside of it. and you can only see it as one entity inside the ArcPro or inside the Arc catalog. Other than that, if you look at it from the drive, you will see a litany of files that might make no sense at all. And of course, one of the formats we use is normal tables, whether it's DBF tables or Excel tables or CVS tables. Most table formats you can actually add to GIS, and there are techniques by which we can join those tables to spatial data if they are relevant to it. Okay, this is actually a view of what we see usually inside a geodatabase, whether it's a personal geodatabase or file geodatabase. We have something, the main thing is the feature class. It could look like this, just square with dots or square with lines or square with polygons on it. So any one of those views is a feature class. And it's just like that. It's a container that has point or line or polygon geometry features. Sometimes we can collect a number of feature class in what is a feature data set. A feature data set is something like a folder where you can collect several files on it. But in ArcGIS systems or in geodatabase systems, when you move into a feature data set, you're basically moving because all the files, all the features that are inside the data set coincide in the same spatial extent. So basically, let's say, for example, I have a database for Egypt, and I have feature classes for the Nile, for the cities of Egypt, for the North Coast, for the Red Sea coast, and so on. And each feature class one of those, they are all in Egypt. So I can actually create a feature data set, call it Egypt, and add all those feature classes inside of it. But I can, for example, come to get a feature class for the Everett River in Iraq and say I'm going to add it to the feature data set. It has no place there. This is Egypt. This is not Iraq. So adding it there, it does not coincide with the data there, and it will not work. And if you set your feature data set right, because feature data set has something like an XYZ to the feature data set as a whole, it has some form of a coordinate system in it. It will not accept something from Iraq because it doesn't fall into Egypt. You can have tables, domains. We might talk about it a bit. We have relationship classes. Relationship is something that we usually set between feature classes with each other or feature classes and tables. We can have some form of typology features, geometric network. Those are, I mean, there are many here that are a bit advanced, so I'm not going to talk about it a lot, but they are there. You can just think of it that those are the formats that we deal with. And even raster datasets in the file G database, I can save in file G database raster data directly. They will not have the original formats, but usually we do that when we have either satellite images or we have raster data we're working on, some vector data we had, and we turn it into raster data, and we deal with it inside the database itself. Now, in the next slides, we're going to go through the interface, quickly through the interface of ArcGIS Pro and the different functionalities of it. And then we're going to open the software itself and start looking at redo the review again. This is just a quick review of the functions, and then we'll open the software and see all that together. So if you click the Windows window button and you get the start button and you check after you install the ArcGIS, you find these are the litany of the programs that come with it. Usually you find Arc Catalog 10.8.2. This is also one of the programs that are related to what we call here ArcMap 10.8.2. Those are the old programs. We have also ArcGlobe, ArcScene. Those are the old programs. ArcScene dealt with 3D data. ArcGlobe, when you opened it, you have a globe like what you see when you open Google Earth at the start. This Earth globe that starts turning until it stands at where are your geolocation as right now, and then you start navigating. So you get this, you get a globe, and then you can add your data to that. You add your data to that globe. Right now, no one of us uses, maybe we use ArcMap a bit because there are still data that are more into the formats of ArcMap. But we're all shifting to ArcPro, which is the software. We're going to talk about it now. The ArcPro is the main program and the main interface we work with. And many of the functions of the ArcGlobe and the ArcScene or the ArcCatalog are already incorporated inside of it. So we're not going to miss it. It's basic that was the main idea beside the behind the ArcGIS Pro, is that it would incorporate all that multitude of suites into one program, so that I don't have to move between this program and that program and that program as we did in the old days. Now we can just use one program to do everything. Nowadays, if you're going to move somewhere, you're going to move online, not to another desktop application. Also, you'd find here some program called City Engine. City Engine is also an Esri program that deals with designing and building cities. It's mostly in 3D, and it has many applications, and we are going to talk about it a bit later. Okay, this is the main interface of ArcGIS Pro. First, we have the ribbon. It's basically the ribbon that you can find in any office software. So this is the ribbon, and you can move between the different tabs. Every tab opens a new ribbon for you. You can use whether it's the map or the insert or the analysis or the view or the edit or the imagery or share, appearance, labels and data, and so on. So we have the ribbon here at the top. We have the projects tab. If you tap this, you move to a totally different interface that basically shows you the projects that you have and other options of the software. Here, this is the map view, or this is the viewer. Okay, this is our viewer. It could be a map view, it could be a layout view, it could be a catalog view, it could be a scene view or a 3D scene view. So this is the view here. This is the contents. It used to be called the table of content or the TOC. If you're looking at any old documentation for ArcMap or something like that, you might sometimes find this acronym. Check the TOC or the TOC, which is the table of content. Now we just say it contents, and that's it. And here we actually add all our feature layers. We place them as layers. We define the symbology, define how it would appear here on the view, and so on here in the contents. Here we see the view of the attribute table. So this is the table view. As I said, every feature that we have here has two views. It's the geographic view or the attribute view. Or the table view, as we say, attribute table. So this is the attribute table, and it also internally have a couple of views. We'll look at it quickly. And here on the side, we have the catalog pane. Basically, right now it's the catalog pane, but I can open several other panes here. You find some tabs here on the lower right side, either it's catalog or geoprocessing or whatever other tab we opened, and we can see it from here. The catalog gives us a view similar to the tree that you get when you open the Windows Explorer. When you open the Windows Explorer, you get a tree here on the side that says these are the drivers that you have, the C, the D, the E, and if you click on any one of them, it opens on the side you view the files that you have. The catalog is used in the same fashion. It's basically what the files looks like, the files that you have looks like, and you can click on any one of them and simply add it to the content, and it will directly be added to the map. It has other uses, of course, and we'll talk about that. This is how it looks like if we clicked the projects. If we clicked here the projects tab, this is what we are going to see. Basically, those are the projects, the recent projects that we worked on, and they give us option: are we going to new project into map or into catalog, or into a global scene or a local scene? We have to choose from them. It also gives us the ability for learning resources. I heard before in the start, someone of you were saying that you're using YouTube to learn a bit about GIS. And it's a resource that we use, but we only use it if it's a very specific analysis that we're trying to learn, and we can find it in the learning resources of ArcGIS. They have quite a very extensive learning courses. Many of them are free, so you can actually access it either from here or from the website and start using them directly on the ArcPro or on the web browser, and we learn a lot from that. And of course, you get the settings or the options of the program itself, and edit what you need for it. And please don't do anything in the settings unless you know what you're doing. So it's not for anyone. Okay. This is the first thing we do when we when we open a new project is to load data or import a map. Basically, when you open a project, it's empty, and you have to fill the contents. The content span is empty, and you have to fill it. So either we're importing maps from somewhere on the a map that is already saved on our hard disks, or from previous projects, or from some data we collected from somebody else. We're going to import it from here. Or we have something like loading data in the maps. We're also going to check it, and then we add the maps that we want. Also, we can add maps from the catalog. As I said before, you can just right-click any map you have in the catalog and simply say, open it, and it will open in the map you're working on right now. The other view is going into maps and asking to add data. And this is usually something we do when we are not adding an entire map, but adding data from a geodatabase itself. We're going to see that as well. You open a geodatabase and start asking, okay, I want this feature, this feature, this feature, feature classes. I want those feature classes, and add those feature classes to choose them, and they will be added directly to our table, our contents. I'm used to call it the table of contents. So if I do that, just forget about it, but add it to the contents, and whatever is added here, you can see into the map view directly. Whatever is loaded in the contents or in the table of contents, you'd find usually a tick beside it. The tick means is it visible or is it invisible? So if you tick something else, you tick any one of them, remove the tick, it will show in the map, or basically turn it on and off. You can also decide on what is the symbology that will look on. There is an access format to the symbology features, and you start editing how it would look. So something like that, looking, for example, the parcel boundaries and how it is defined with different colors. I can choose that, enter that interface from here, and decide on it. I can also change the labels. Instead of calling it parcel boundary, I can call it something else together. Just click on it a couple of times, and you can just rewrite what it's called. Of course, that rewrite is only here in the contents It doesn't change the original data, but this is just something like a viewer, so I'm editing inside of it. Also, something that we use, as I said, on the viewer, is the viewer a map or a layout or a scene? So when we use the word map, this means that we are basically looking at those features in 2D. So maps usually look at features in 2D. They are not in 3D. You can also add data from them. If you right-click on it, it's called here green areas. For example, this map called green areas, I right-click on it, and it basically asks me if I'm going to add data, set a reference scale, do I want labeling turned on or turned off, and so on. I can add several of them, and also I can come here and say save a map file, and this is the map file that I imported on the first slide here. When we say importing maps, this is what we mean by it. What I saved as a map, I can import as a map. On the other side, there we have what is called as feature layer, and this is also part of the terminology of ArcGIS. In ArcGIS, we have the features, and we have the feature class. Feature class is basically a collection of features that have the same geometry, so and same attributes, same geometry and same attributes. So if I have a feature class for roads, it means that all the features inside this feature class is of course lines, because roads are represented on maps usually as lines, so it's only lines. You can't have a polygon, you can't have a point in it, and at the same time they are all roads. I wouldn't have, for example, a transportation line within them. It doesn't make sense. I wouldn't have a sewage line or a water pipe in this feature class, because this is a feature class for roads. So all the features inside it carry the same function. So we call that a feature class. When we load the feature class inside the contents band, we call it a feature layer. It's a stupid distinction, but it's an important one, because a feature layer is an image of the feature class. It's not the actual feature class. The actual feature class is saved on our hard drives, safe and sound, without change to its data. And this is also one of the most important tenets of GIS systems. Data is expensive. To create data, to whatever maps you're going to create, whatever geodatabase you're going to create, creating this, collecting this data, integrating it all together is expensive. And so you don't want it to be ruined by a stupid mistake or something like that. So usually what is loaded in the content span is an image of that data, not the actual data. When we go to edit, when we want to edit the actual data, it's a whole new thing. So if I look at here at the feature layer and I right click, and I get also options. I can copy, I can remove, I can group, I can open the attribute table, I can play with something called data design, I can create charts if I want, I can zoom to layers, I can make selections, I can open labeling by some sort of another, and I can of course go to symbology, which will open a different band for me to try to make the symbology of the features. If we check the table of attribute, this is how the table of attribute would look like. This here is the table of attribute. What we have here, the rows, is what we call the record. All rows are called records because each feature have one record, as we say. Each feature has one record, and usually those columns we call the fields. Now, some fields will have an apostrophe or a small star behind the name. Those means it's generated by the system. So when I created the data, the system creates those two. One here is the feature ID, FID is feature ID, and the second is the shape. Of course, this is a feature class that was actually points, so the shape is point, and it's basically repetitive. For every record, it will just write points. It cannot write polygon or line. As I said, feature classes has to be of the same geometry. And then the rest of the data, the rest of the fields are fields that we entered, whether it's object ID, city name, admin name, country, population, port ID. All of those are data that whoever created this feature class called city were responsible for creating and adding. Another view of the attribute table is looking at the fields. We look here and we see, okay, those are the fields that we have. If I want to turn some of them visible or invisible, I can click on it. If I want to have it to have an alias to its name, for example, I don't want to have city name. I want to have to say just name. So I can jump into the alias and change that. I can change the field name. Once it's entered, it's entered. This is, once it's done here, it's done, and we can change that. But I can change the alias all the time. We can also change the, we can also decide on the data type. Once we decided on that, it also cannot be changed, and we'll talk about that a bit tomorrow, not today. And this is another view. And of course, once we are in the attribute table view, we come here to the ribbon on the top, and we'll have table, and in it we can see different functionalities inside the table that we can use, different selection tools or tools that has to do with calculation or statistics and so on in here, and whatever changes we can do. Usually at the end you find something like save or discard changes, so we can just save what we do. Another thing we have is the layer property. So any layer we are on, if you check here on the layers, you have something called properties. At the after the right click to open this menu, you have something called properties, and this is the properties interface. It basically gives us different attributes to that, different property to that feature class that we're on. So I can go to the general, change its name. Here also we're changing something like an alias, not the actual name. Play a bit with the scaling and the extent, add some metadata, and we'll talk about that. Check where the data, the source is actually where the actual data is stored. Add something to the elevation, selection, the display, add something called the definition query, play with the time, the range, and so on. So it's basically the main attributes of the main properties and settings of the feature layer that we already loaded. We can come here and play with those properties in it. That should have been deleted. That's the old symbology from ArcMap. So it's not relevant to us. This is the new one. Okay. This is how the symbology looks now. I can right click on any feature layer, click on symbology, and it will open a band on the right. That is basically the symbology band. And in the symbology band, you start with, okay, what sort of symbology I'm going to use. What field? Usually, if I go here for unique values, they offer me the idea of changing this data based on fields. So this feature layer was the land use. This is the land use for Cairo, for example, the data that I'm loading. This is the land use for Cairo. And basically, I have a field inside of it called land use that has a different land uses. And basically, I'm loading only the land use for the agriculture or the green areas, the different green areas inside the city. So I'm loading that, and basically it's loaded here. I have the color scheme where I choose, okay, I want all of them on a green scale, so I can choose that green scale. I can change it if I want, however I want, and it's added here. And this is all the data for the green areas in the city. And once you have an application button down here, you click it, and that's what you see on the map view. These are the options that you can get from the symbology. So later, before we were on unique values, we can have a single symbol. Basically, it has nothing to do with the fields anymore. It's simply whatever on the feature class all take the same color. So that's the single symbol, and then you have unique values, which basically gives each feature in the feature layer a specific color based on data from one of its fields. We have also other symbology types like the graduated color, bivariant color, unclassed color, graduated symbol, and so on. Each type of those depends on taking some data from the fields of the attribute table of the feature layer and coloring each feature or making a symbology on each feature based on it. The other one here is the color scheme. We have many color schemes. It's basically a color scale. There are grayscale. There are some random ones. There are ones that have only going into a certain color, like this is all gray. Sorry, this is all green, or this is all degradations of violet, or degradation of red or brown, and so on. And based on it, the coloring will match here. We just choose the color scheme or the color scale, and whatever features have colors here, it will show here. And of course, if I want to choose each color of those separately, I can also do that. If I just click on one of those, I can change the color however I like. So that's the symbology. Are you with me right now? Did I lose anyone?
I wanted to ask this same question. So to what extent can you grasp all what
we're going to do that on the software, because I'm going to open the software now after we finish this. This is just to have a look on those different functionalities, but then I'm going to open the software and start doing that on the software. So I'm just making here an overview of the different functionalities.
Does any one of you has a question regarding what Monam is saying?
I have one question.
Yeah, please.
I don't know what the single symbol meaning. It's only to draw a layer, only one layer, not a categories.
Yeah, the data is not categorized.
Okay.
So it's just one color. So if I, for example, this land use, this feature layer that's called land use, this layer called land use, this is basically a map of all the land inside Cairo. So all the blocks of the land in Cairo is drawn, and to each piece of land in the attribute table, the land use basically says what's the use of this land. Okay, so I have that, and I have the database that says this is residential, this is residential land, this is a park, this is a school, this is a hospital, and so on. When first I load the data, when the first time you load the data, it's usually in single symbol. The system doesn't know how you're going to categorize the data, so it's just in single symbol, meaning that all the land that I have just loaded on the system have the same color. It's not recognizable. The land for the residential from the land of the school, from the land of the parking, they are not recognizable from each other. They all have the same color. Okay. Until I go to the symbology and start saying, okay, I want it to have a unique value, or I want to have it as a graduated color or a graduated symbol, and so on. So once we move from single symbol to the other categories here, we actually start to categorizing the data and visualizing. And this is one of the first visualization techniques we use, is visualizing the data we have. We didn't start the analysis, but we can start visualizing parts of that data to make it more accessible to ourselves.
Okay, thank you.
Do we have any further questions till this step? Do all of you understand the differences of the layer types and symbology types that Monam was mentioning earlier, like the line, the polygon, the point, and so on? and how to use them and when to use them. Hello, are you there?
Hello.
Yeah.
Yes, I understand, but I am waiting to see it live application on the software, so to recognize all the steps that led us to this whole of thing.
Okay.
Okay.
Okay, moving on, we have queries. If you remember the functions of GIS, we talked about earlier, this is the third function, making a query. Making a query is basically asking simple question, and queries are inside the system are known as select. So it's select by attribute, select by location, or simple select by, if you check here, you have this one, it's select by window. So I can just open a window here and whatever is inside the window will be selected. Or the more refined tools, which is select by attribute and select by location. Once anything is selected, you'd have here the span with the more of this menu will be the grayed out will be blackened, and you can choose it. So you can zoom to selection, band to selection, you can clear it, you can switch it. Switch it is basically inversing the selection. Whatever is selected is unselected, and anything else that was not selected will be selected. So that's switch selection, and so on. So let's check quickly what is queries. So this is select by attribute. This is the new form of select by attribute. This is the one we used to have in ArcMap. This is actually SQL. What is written here, this is SQL format or partially SQL format. And we used to write that double-clicking here and then choosing what we call an operator and then choosing something else. So, for example, here, this is about streets. So the class of the street or class description of the street equals major highway. And when we click OK, any street in the map that is actually classified in the attribute table as a major highway just lights up. So we already selected it. This is how it used to look. Now this is how it looks. I'd say it's more refined. Many of those operators, the basic ones were ones that we all know and there was no problem with it, but check those out. Those doesn't mean what you think you mean. I mean, those are very different operators and they have to do with SQL operators. So this doesn't mean what you think it means. So this is much easier. It's written in format. So you know it's equal to, not equal to, begins with, does not begin with, ends with, and so on. Those are the operators. And what we do is basically say, okay, I'm now on the feature layer that is called land use. In the feature layer called land use, there is a field called land use. So in land use, I want land use is equal to something, some data from this side. I choose that, and when I click apply, it selects. So if I said is equal to green areas, that's all what I will get. That's all the thing that will light up. It is already selected. Another important point of select by attribute is what is the type of selection. Here it is, the default is new selection, but in reality it could be a new selection or add to current selection or remove from current selection or select a subset of the current selection or switch the current selection or clear the current selection. So let's take the first four. They are the important ones. New selection is just that. It's a new selection. So when we run that, if there is anything that is selected before will be removed from the selection, and it's a totally new selection will be created for us. And then we have add to current selection. So whatever we have selected becomes a subset, and the new selections that we make are going to be added to that selection. we have the reverse here, which is removed from current selection. So I'm making a selection, and then whatever I'm going to query will be removed from that selection. Let's say, for example, I said that I'm selecting all the green spaces in Cairo. So I've already selected the green spaces in Cairo, but the green spaces have different categories inside of it. They are we have parks, we have recreational areas or recreational clubs, we have some social areas. I mean, there are different types of green areas, and I say, okay, then I'm going to remove, for example, social clubs from the green areas. So remove from current selection, and I make the query based on this category. And so social clubs will be removed from the green areas. So I only have, for example, the pure green areas. And of course, we can, instead of removing from current selection, I can reverse that and said, okay, select from the current selection. So whatever the current selection is, select from it. So don't look at the entire data we have, only look inside the selection and select from it. Beside that, we can also create what we know as a compound query. So this query has two conditions, and we're looking to find the features that satisfy those conditions. So we say here land use is equal to, this is monuments. So to those who don't speak Arabic, this is monuments. And here we have also a field called district, and this is district Azhara. This is a district in Cairo. So basically I'm saying land use is equal to monument and district is equal to Zahra. And then we come to this operator, which is important. This operator have two types. It's and or. So and or. That's it. Those are two operators. When I say and, basically we're saying whatever is going to be selected must satisfy both this condition and this condition. It must satisfy both conditions. When we choose the operator, which is or, now it's this condition or that condition. Whatever satisfies this condition or that condition is chosen. It is not necessarily that it satisfies, that the feature selected satisfies both. It's just important that it satisfies at least one of those conditions. Okay, and we'll check that as well as we move on. Okay, so this is select by attribute. Another type of selection is to select by location. Now, selecting by location based on the spatial relevance between one feature and the other. So I can say here, for example, we have land use and we have access. Those are the main roads, arterial roads in the city. So I'm going to choose the land use that are within a distance from an axis, and that distance is 100 meters. So whatever feature, whatever land parcels that we have that are within 100 meters from the axis will be chosen, and that's it. And of course, now we have as well, this is what we call the operation, which is the operator, which is here called the relationship. And what type of operators we have? We have intersect, we have within a distance, we have contains, completely contained, within, completely within, and so on. And some of them you find 3D beside it, because sometimes the data you have has a 3D function in it. It's not just XY, no, it's X, Y, and Z. If I only say intersect or within a distance, it only dealing with the XY. If I said 3D, if I said within a distance and 3D, it also adds the Z factor and calculates in 3D. Okay, so this is the select by attribute, and this is the select by location. And sometimes we have a combination between the two. I select something by attribute and then move to select by location. And when I do, you see here the blue line here, it said the input has a selection record to be processed is 0. Basically, it says that there is nothing is selected in land use. If there's something selected in land use and I run this query will only run against the selected features. It will not check the unselected. Once a selection is done, this is the view that we get. In the table view, you get those highlighted blue lines. Those are the features or the records of the features that are selected. And you have two tabs here on the below. One of them is this view, and the other one, when you click it, you only show the selected. Those ones that are not highlighted will disappear, and you only see those in the attribute table. At the same time, you also have those functionalities that I said before are usually dimmed until we have a selection. So whatever the selection is, I can simply zoom to that selection, and the features will we will zoom to that feature, and we'll start working from there. Okay, another feature we have is layouts. Now, all we talked about right now, we were talking about the map view and what we're going to do with the, whatever functions we were doing inside maps. Now we're going to present those maps. We are done with our work, we're done with our analysis, and we're going to present our maps to somebody. And the first thing we do to present that map is to go into layout. So we create a layout, and the layout is defined by this. It's a piece of paper, and you can add north arrows, you can add scale bars, you can add legends, and of course you add your map. You can zoom in, zoom out from that. You decide the extent what you want to show, and then you have the different options, and then this map is presented to your audience, to your clients, to your students, however you want. Either you can add it as you can export it as an image, you can export it as a PDF file, you can even add it to a web interface, and so on. When you create the map, this is the layer properties, what you layout layer, and you go inside it, and they ask you, do you want to create what size paper you want? So this, for example, was an A2. I can decide a different size, portrait, landscape, and so on. I can go to general and find the name of the map and add those, change the name of the layout, sorry. So I can decide what the name of the layout will be. We'll talk later about map series and so on, because it's important. Metadata is a function. It's something we call data about the data. It's a joke in GIS lectures, I think. You always come to metadata. It's data about the data, and basically when you stop on metadata, they give you the idea about, let's describe your layout. What's it about? Who owns that thing? When was it created? Who has the copyright, and so on. So you can add all this data here, and it's the metadata that you have for this file. Once you export it, usually if exported as a PDF or something like that, the metadata will also be exported with it. So this data will carry on. Okay. So this is the overview of the program. Next, we will move to the program itself and start tinkering with it. So maybe we granted another short rest, a 10-minute rest, and then we continue.
Oh yeah, thank you, Abdulmanam. So before going to the short break, anyone has a question or something to ask?